The Sun is more than just the life-giving force that sustains Earth. It is a volatile, dynamic powerhouse capable of unleashing unfathomable energy. Recently, our star demonstrated its unpredictable nature with a solar storm so powerful it defied expectations. Auroras, those mesmerizing celestial lights typically confined to the polar regions, danced over Florida and Mexico, painting the skies in hues of green, red, and purple. While this spectacle captivated millions, beneath its beauty lurked an ominous truth. The storm wasn't just a light show, it was a stark warning of the Sun's immense and often underestimated power. Satellites faltered, power grids teetered on the brink of collapse, and scientists scrambled to assess the long-term implications. What caused this unprecedented event? And more importantly, could something even more destructive be on the horizon? The culprit was a sunspot of extraordinary proportions, known as R3664. Imagine a dark, sprawling region on the Sun's surface, so vast it could comfortably fit 16 Earths side by side. Sunspots like R3664 are not just blemishes, they are regions of intense magnetic activity, often serving as harbingers of violent solar eruptions. Over a span of days, this sunspot unleashed a barrage of X-class solar flares, the most potent category, alongside multiple coronal mass ejections, or CMEs. Each of these phenomena alone is formidable, but together, they create a cosmic storm capable of disrupting life on Earth in ways that few fully comprehend. To grasp the sheer scale of these events, consider the dynamics at play. A solar flare is a sudden, intense burst of radiation, akin to a lightning strike that occurs on a colossal scale. The energy released in a single flare can outshine billions of nuclear bombs. Within minutes, the flare's radiation reaches Earth, disrupting radio communications and damaging satellite electronics. CMEs, on the other hand, are massive expulsions of solar plasma and magnetic fields. These ejections travel more slowly than flares but pack a long-lasting punch. When a CME collides with Earth's magnetic field, the resulting geomagnetic storm can wreak havoc on power grids, navigation systems, and even undersea communication cables. Together, these phenomena form a deadly cosmic double punch, capable of bringing modern civilization to its knees. The recent solar storm was a prime example of how interconnected our world has become and how vulnerable we are to disruptions from space. Communication satellites struggled to maintain functionality as the storm intensified. Airlines rerouted flights to avoid high radiation zones near the poles, while power grid operators worked around the clock to prevent blackouts. The event served as a grim reminder that while we may have harnessed advanced technologies, we remain at the mercy of our nearest star. But this isn't the first time the Sun has demonstrated its destructive potential. The Carrington event of 1859, often cited as the most powerful geomagnetic storm in recorded history, offers a chilling precedent. Back then, the storm ignited telegraph lines, causing fires in offices and rendering communications unusable. Auroras illuminated skies as far south as Cuba, leaving early observers in awe. Today, however, the stakes are exponentially higher. A Carrington-class event in the 21st century could devastate global infrastructure. Imagine satellites falling silent, internet connections severed, and entire nations plunged into prolonged darkness. The financial cost alone is estimated to exceed $2.6 trillion, but the social and economic fallout could be even more profound. In recent years, scientists have ramped up efforts to understand and predict solar activity. Spacecraft like NASA's Solar Dynamics Observatory and the Parker Solar Probe have provided unprecedented insights into the Sun's behavior. These cutting-edge missions capture high-resolution images, measure solar winds, and monitor sunspots like R3664 in real time. Artificial intelligence has also become a critical tool, analyzing vast datasets to predict potential solar storms days or even weeks in advance. Yet, despite these advancements, there's no surefire way to shield our planet from a massive geomagnetic storm. Our technology may give us a glimpse of the sun's intentions, but the question remains, are we truly prepared for what might come? The implications of solar storms extend far beyond power outages. Industries we rarely associate with space weather, such as agriculture, finance, and logistics, are intricately tied to systems vulnerable to solar disruptions. GPS technology, crucial for everything from crop management to global trade, could become unreliable during a severe storm. Financial markets, which rely on precise timing for transactions, could face unprecedented chaos. Even emergency services could be hampered if communication systems fail. It's not just a question of technological resilience, it's about safeguarding the very fabric of modern society. Space exploration also faces significant challenges from solar activity. Ambitious plans for human missions to Mars and the establishment of lunar colonies hinge on our ability to protect astronauts from solar radiation. A storm like the recent one could expose spacefarers to lethal doses of radiation within hours, jeopardizing missions and forcing us to rethink how we approach the final frontier. As humanity ventures further into space, the sun's temper becomes an ever more pressing concern. What makes the current situation even more critical is the timing. We are approaching the solar maximum, the peak of the sun's 11-year activity cycle. During this period, sunspots like our 3664 become more frequent and more volatile. The recent event is likely just a preview of what's to come. In fact, our 3664 remains active, and scientists warn that it could produce additional flares and CMEs in the near future. The question is not if but when the next storm will strike, and whether we will be ready to face its consequences. The sun's activity also raises profound questions about the nature of our universe. Why do sunspots cluster together in certain cycles? What triggers the most powerful solar eruptions? And could understanding these dynamics help us predict storms with greater accuracy? These mysteries are more than academic, they hold the key to protecting our planet and ensuring the sustainability of our technological advancements. At Discovery 2.0, we explore these interconnected themes of science, technology, and human resilience. The sun's recent outburst is a vivid reminder of our place in the cosmos, a delicate balance between awe and vulnerability. As we marvel at the breathtaking beauty of auroras in unexpected places, we must also acknowledge the urgent need to prepare for the challenges ahead. The sun's power is a force of nature we cannot control, but with ingenuity, cooperation, and determination, we can mitigate its impacts and safeguard the future of our civilization. The sun may be 93 million miles away, but its influence on our lives is immediate and profound. It warms us, sustains us, and occasionally reminds us of its untamed power. Let this event serve as a wake-up call, not just to scientists and policymakers, but to all of us. The universe is vast, mysterious, and sometimes dangerous, but it's also a testament to humanity's unyielding spirit to adapt and thrive.